Thank you, Lindsay. My name is Keith Hambrecht. I am the Restoration Program Manager for State Lands for Utah Division of Forestry, Fire, and State Lands. And I have been working on Phragmites control for 10 years now. So I figured we'd start here, just in case. What the heck is Phragmites? Phragmites is a plant. It is a really tall perennial grass that's found in our wetlands. It can grow 12 feet tall or higher, and it forms vast monocultures. It is highly invasive and it is non-native. Phragmites is actually the genus of the plant. The non-native species that we have is from Europe. It's Phragmites australis australis. We do have a native species, Phragmites australis americanus, but that native species is a very small component of the Phragmites that we have in the Great Salt Lake watershed. The native one is very common on our desert rivers. So I figured just right off the bat, I would tell you, here's what I want you to know about controlling Phragmites. So Phragmites has a significant impact on Great Salt Lake, but Phragmites can be effectively controlled. And the efforts that we've currently taken to control it are worth it, and they're presenting many win-win scenarios. The current investment in Phragmites control is paying off, and we're seeing significant progress. And there's also a lot that we know about controlling Phragmites and restoring native plants to the wetlands, and there's still some things that we need to figure out. What's important to note is persistence, follow-through, and strategic collaboration, and continued funding will be needed for many, many years to see this through. And patience. It takes time to remove Phragmites from these wetlands, and also it takes time to restore the wetlands. So just getting into the details for the impact to Great Salt Lake. First and foremost, Phragmites has a significant impact on habitat and biodiversity, as these two photos show. So on the left is a field of alkali bulrush. This is out in Bear River Bay. That alkali bulrush is our native wetland, is a native wetland emergent plant on Great Salt Lake. You can see it is only a few inches tall to maybe up to 2 feet. And it's also not growing that dense. You can also see there's still large pockets of open water. That's what our birds use and have to have access to the water and to the plants and to the bugs that are in the soil. Compare that to the photo on the right, which is a Phragmites invaded wetland on Great Salt Lake. It's incredibly dense, impenetrable, and you could imagine significant impacts to the wetlands. The birds cannot get access into these areas at all to feed or nest. Additionally, Phragmites has a significant impact on water for Great Salt Lake. So for surface hydrology, you could imagine as we're shepherding water to the lake, if it hits a patch of, like the Phragmites that's on the photo on the right there, it's going to block water flow to the lake. It'll also trap sediment, so it'll actually raise the elevation of the wetlands. And what that does is actually dries out the wetlands and makes them essentially no longer a wetland. In addition to that effect on surface hydrology and blocking water flow, there's also a big impact on water availability in the wetlands due to evapotranspiration. So Phragmites, because there's so much biomass, it transpirates a lot more water out of the wetlands than the native plants do. We have some preliminary estimates on that, where if we were to remove Phragmites from the bed of Great Salt Lake and replace it with native inland saltgrass, which is a native grass that would grow in a similar habitat, we estimate we could save 82,000 acre-feet of water per year for Great Salt Lake. Additionally, it has a huge impact on recreation. And then also, I did want to mention for the surface hydrology, so if Phragmites is blocking the flow of water on Great Salt Lake, that's also inhibiting sheet flow onto the lake bed, and that sheet flow is what creates much of our bird habitat. That's also what is going to keep dust down. As we know, the most effective way to control dust is to get water to the lake. So just to illustrate how significant the invasion of Phragmites was on Great Salt Lake, here's a photo of Farmington Bay in 2003 after the floods of the 80s receded, and it's a giant salt flat with very little plant matter at all. Here's just 14 years later, that same area. Again, I have a peak in the background highlighting that same location, thousands of acres of Phragmites. That's incredibly dense. This photo is actually taken on top of a truck, on top of a dike, looking down into the Phragmites. Okay, so how do we control Phragmites? Just really quick, we're lucky that we have a lot of great local research that we've built into best practice guides for everything related to controlling Phragmites, and then also now how we revegetate after Phragmites is removed. In a nutshell, we have to use systemic herbicides to kill Phragmites because it is a perennial plant. We follow that up with either mowing or burning. We have to repeat that for many years to kill any given patch of Phragmites. And then once we've done that, we can change up our water management and do revegetation and maintenance. We build all of these best practices into treatment protocols that really dig into all the details of the specifics of each site and water management. Let's see what else is important to cover. So for the herbicide treatments, the local research, what it told us was end of season, late spraying is most effective. And also, if we spray drought-stressed Phragmites, the herbicide is not effective. So the timing and the conditions is really important for effective control. So we've been applying this treatment method and learning all these details over many years now. For Utah Lake, we're also controlling it on the bed of Utah Lake. We're now treating the entire shoreline of Utah Lake each year. So we have a complete data set to estimate our progress. And as of last summer, we've reduced Phragmites cover on the bed of Utah Lake by 88%. We think we'll be in the 90% this season. So we know what we're doing is working. Great Salt Lake is just 20 times larger in size as far as the wetland area that we're working, so we know it's going to take more time. But as far as Great Salt Lake goes, although we don't have a complete data set, going back to this photo in Farmington Bay, WMA, here's that same peak labeled. And then after 5 years of treatment, we've completely removed Phragmites from this area. We had some monitoring for many years following up. We had 7% Phragmites cover in the project area, and this area is now vastly different. So all this vegetation is very short, a few inches to maybe at most around 2 feet tall. We have open water, bare ground. There's a ton of bird use in this area now that there was not before, and we're able to sheet flow a lot of water across the lake bed. Okay, so what is needed going forward to continue this? We know we need to continue our efforts to remove Phragmites. We know we need continued funding for Phragmites. And then we also really need to increase our efforts to control upstream sources of Phragmites. So Phragmites spreads well by seed as well as by plant parts clonally. So we now need to make sure we're protecting our investment on the bed of Great Salt Lake by removing those upstream sources, and that's very complicated. And specifically, one thing we need to do is develop methods for addressing erosion, because in order to control Phragmites on moving waterways, a lot of these moving waterways, Phragmites is the only thing that's holding the bank together. And if we just go gung-ho removing Phragmites up and down the watershed, there'll be a lot of negative impacts. So that is quite challenging. We really need to ramp up our revegetation efforts. We've started to do that, and we need to keep supporting research to help us understand that restoration. We need better mapping. We need to map Phragmites on a large scale so we can track it over time, and then also on a project scale so we can make better management decisions for maintaining what we've gained. And then something that I haven't talked about thus far is encouraging and supporting staffing and capacity at different levels of government for Phragmites control. So I am managing the work that's on the bed of Great Salt Lake. I have colleagues at Division of Wildlife that's managing Phragmites in WMA areas. But then you go to the rest of the watershed, and it's a whole bunch of different ownership and management. And a lot of it is maybe cities and municipalities or areas where you might have landscaping people or parks managers, but you don't have restoration experts. You don't have open space experts. So we need to think about how are we going to support the boots on the ground to do this work. And of course, as I mentioned before, persistence and patience, it does take time. But in a decade's time on Utah Lake, we saw significant progress. We just need to keep at it. And then specifically, we need water. So we know that we need water to effectively treat and remove Phragmites. These wetlands need water, but also our estimates for water gains for Great Salt Lake, those are only realized if water is delivered to the lake bed. Here's my contact info, and looking forward to talking to you guys at lunch.